Okay, cool. So today I will talk about 3D printing of polymers versus 3D printing of reinforced polymers. So additive manufacturing, which is more commonly referred to as 3D printing, is quickly approaching mainstream adoption as a highly flexible process technique that can be applied to plastic, metal, ceramic, concentrate, and other building materials. However, taking the advantage of tremendous versatility associated in photopolymerization, as well as the ability to select from a variety of performed possible polymers. 3D printing predominantly targets the production of polymer parts and models. For now, there are two manufacturing processes. One is 3D printing of polymers, which is a conventional manufacturing process. Another one is advanced manufacturing process, which is 3D printing of reinforced polymers. In the following slide, I will introduce the compatibility, limitations, advantages of new manufacturing process compared with conventional one. To begin with, in polymer 3D printing, there are five common methods: SLA, FDM, SLS, FDM, and material jetting. And for each of them, they all will have the impact to a material microstructure, their size, their shape, and the orientation of the grain of crystals. To be specific, SLA rely on the liquid photocurable resins. They are selective cured by a UV lasers layer by layers, causing the resin to solidify. However, these methods tend to be less durable than parts produced with other additive technologies. Also, since SLA materials are sensitive to UV light, their mechanical property can change due to the overexposure to sunlight, thus make them unsuitable for outdoor using. Talking about second method, FDM has evolved to offer a great reliability, accurate, and material choice, making it suitable for a number of production applications such as manufacturing aids. One of the main limitations of the FDM parts is anitrop, anisotropy, meaning that their mechanical properties are not equal in all dimensions. And this weakness can result in weaker parts too. What more, FDM also has slower printing speed than other 3D printing methods. Thirdly, with a combination of high accuracy, speed, reliability, and lack of support structures, SLS is used both for functional prototyping and low volume production. However, this disadvantage is pretty obvious. SLS technology is really expensive for a company to repair. Compared to SLS, due to the hoop, MGF have a really faster workflow, which can speed up the cooling process and ice in powder process. However, the limitation includes limited number of material also become one of the barrier of MGF. For the last one, which is material jetting, one of the key advantage is that this technology has the ability to combine more than two materials together during the printing process. On the contrary, weak material property has already made this process unsuitable for functional application. In this circumstance, a new manufacturing process is desirable. for industry to minimize the shortcut brought by the conventional process. The new manufacturing process will be 3D printing of reinforcement polymers. From the current product, the researchers have concluded that the reinforcement polymers significantly enhance the mechanical property of the structure printed. From the current research article, the incorporation of fiber and nanomaterial reinforcement into polymers allows the manufacture of the polymer matrix composite, which are characterized by high mechanical performance and excellent functionality. One of the possible methods is to improve the strength of FFF parts is adding reinforcing material, such as carbon fibers, into pure thermoplastic matrix material to form carbon fiber reinforced thermoplastic composite. Several studies has been conducted related to FFF and carbon fiber composite. According to investigation of mechanical property of a carbon fiber reinforced nylon film for 3D printing, film made from the carbon fiber and the ABS polymers significantly increase the strength and the stiffness of the final parts. The tensile stress and the stiffness of the composite symbol was 60.69 MPa and 8.91 DPa, respectively, whereas these values for a pure ABS symbol were 29.31 MPa and 2.05 DPa, respectively. On the contrary, there are several disadvantages we will need to discuss and notice before I get in touch with the ground. To be specific, the researchers conclude that reinforced polymers would decrease in toughness, yield strength, and ductility, and increase in porosity with increased carbon bar content. In this case, when we apply this material, we have to make sure that the company would maximize its advantages and minimize its limitation. Furthermore, from the 3D printing fiber reinforced polymer composite structure analysis, its research continues fiber reinforced additively manufacturing, which we call CFRAM. CFRAM components are lightweight, low price, yet strong material with a wide range of potential applications to auto industry, to aerospace, to sports goods, and other mechanical tools. In addition, the researchers also figured out that carbon fiber reinforced specimens generate the highest resistance to failure, and it also has the highest fiber packing density. In this case, researchers will have the chance to study mechanical and structure analysis for potential application in areas include aerospace, automotive, biomedical industry to replace conventional manufacturing process such as 3D printing of polymers. In the conclusion, with the weight weighty distinction of being called the next industrial revolution, 3D printing technology is already alternating many industry and academic operations, including changing models for future healthcare delivery in medical and other areas. In this circumstance, applying and popularization the new manufacturing method play a pivotal role in developing and promote the efficiency of the manufacturing. Yet we do notice that there are some limitations and the disadvantage brought by the new 3D printing of reinforced polymers. But I personally believe that currently this process would be the most efficient way to product and to generate new material compared with other 3D printing process. Thank you very much.